Now, we already went over the HBr addition to an alkene, which gives the Markovnikov product. Now, what if we want the anti-Markovnikov product where the bromine adds at the least substituted position? Well, we can get that, and we need peroxide present. So if you see HBr with peroxide present and an alkene, you're going to get the anti-Markovnikov product where the bromine adds at the least substituted position. Now, why is that? So remember, we said that the HBr mechanism, just addition, goes through a carbocation mechanism, which leads to the Markovnikov product. When we have a peroxide present, we go through a radical mechanism, and that's what leads to the anti-Markovnikov product. So the first thing that happens is we have our peroxide like this, which is going to break up into peroxide radicals. So we're going to get these right here. All right, and then those are going to form a bond with our HBr, where we're going to take one electron like this, single hook, but it's one electron. What are those electrons? We're going to kick one electron onto our bromine. This is where we start doing some stuff. Okay, so we have our bromine radical. That's going to form a bond with our one electron from our alkene, and we get a radical intermediate. Now, similar to the carbocation being most stable at the most substituted position, so is this radical electron. And so the bromine will attach at the least substituted position. And then we're going to have another HBr. We're going to take this radical electron, we're going to form another bond with one electron from here. We're going to form another bromine radical. And that gives us our final product. We're also going to have a bromine radical floating around. It's going to go off and do some more chemistry, maybe get some side product. But that is the mechanism to give us the anti-Markovnikov addition of HBr to an alkene. We need peroxide present, and that peroxide presence causes it to proceed through a radical mechanism instead of a carbocation mechanism, which leads it to add at this least substituted position. If you want to get more organic chemistry learning like this, be sure to hit that follow button.